All right, this next problem is no sweat. It's pretty easy. So let's find the length of the curve y equals 1/2 e to the x plus e to the negative x on the interval 0 to ln2. So there's a formula for the length of a curve. It's the length of a curve L is equal to, in the integral of ds, where ds is equal to the square root of 1 plus dy dx squared. This is just the dy dx term is squared. So our function is y is equal to the 1/2 e to the x plus e to the negative x. So our dy dx is equal to 1/2 e to the x minus 1/2 e to the negative x. And now if we dy dx squared is equal to 1/2 e to the x minus 1/2 e to the negative x squared. So we'll use a FOIL, multiply two parentheses. If you go ahead and do this, you'll get 1/4 e to the 2x minus 2 plus e to the negative 2x. Okay, so if we go ahead and distribute this and then apply the formula, so L is equal to the integral of 0 to ln2 of the square root of. So if I distribute this and then add this 1 over here, I'll get e to the 2x by 4 plus 1/2 plus e to the negative 2x over 4 dx. Now we can basically figure out how to, I guess, simplify this. So if I pull out a square from this, I'll have the following. So I'll have e to the x over 2 plus e to the negative x over 2 squared. So I just pulled out the square from here, so we're left, this term goes away, and these two just become x and negative x. Oops, I forgot to take this over here out. Let me just fix that. Alright, negative x over 2 squared. And the square and the square root cancel out, so we'll have the integral 0 to ln2 of e to the x over 2 plus e to the negative x over 2 dx. So now we go ahead and plug it in. We get e to the x over 2 minus e to the negative x over 2 evaluated at 0 to ln of 2. Plugging this in, we get a value of 3/4. Guys, we've arrived at our first juicy problem. It's not too hard, but you just got to understand what's going on. You got to visualize 2 a bit. I'll show you guys how it's done. So let R be the region bounded by y equals square root of x, y equals ln x, y equals 1, and the x-axis. So state, but do not evaluate the integral that gives the volume of solid obtained by rotating R about the y-axis. So first things first, we're going to draw a graph of what's going on in this problem. So we got to draw our functions that we have here. So y equals root x is sort of looks like this. And then y of, you could just plug in 1 for x and see what it gives you for y, and several values. You'll get a shape like this for y equals x. Let me call this y equals root x, root x. And then for the ln x crosses the x-axis at 1, and it has a similar shape to root x. And then we have y equals 1. y equals 1 is just a straight line here. So the region bounded by these three plots and the x-axis. So that would be the following region. This region here is what if we rotate about the y-axis, what kind of area will we have the integral, basically. So pick a brighter color. If I rotate about the y-axis, what will this solid look like? You got to picture, like I'm taking this and I'm spinning it around and around and around the y-axis. Well, just once. You'll get kind of like a cone shape, not a cone shape, but like this kind of shape solid. Hard to visualize. I mean, I'm probably not drawing it right, but it's circular. The base is circular, and it's just getting a wider radius as you go higher. So if I were to take a thin section of this, I would get something that looks like this. I'm trying to draw this as best I could. Let me try better. Let's try something else. It would be a disc. A disc with the like a donut. So we got two different radiuses here. So we would need to find each radius and then set up the integral, basically. So it's asking for the volume of the solid. So the formula for this would be a dy integral from whatever your bounds are. So we need to find out a couple things here, because we know that the area would be pi r squared minus pi r squared of the inside circle, right? Pi r squared outside minus pi r squared inside. That will give us the area of that disk. So we need to figure out what are our radiuses. That's the first thing. So r and r. I mean, this outer circle here is this function here, right? This y equals ln x. But I mean, it's not, the radius is not ln x. It's got to be in terms of y, because I mean, the radius is in the x direction. So if we can rewrite this in terms of y, we would get x is equal to y e to the y. So that's our radius. That's our outer radius, e to the y. And if we do the same for the other function, because that's the inner radius, we would get x is equal to y squared. And that's our inner radius here, y squared. So now we've got outer disk pi e to the y squared minus inner disk pi y squared squared. So it's not that bad. I mean, it's a pretty easy problem. We've set it up. Now just write the integral. Where are we integrating from? We're integrating from the x-axis to our upper bound, right? So 0 to 1. So 0 to 1. Write our function down. Factor out the pi. E to the y squared minus y squared squared. And then we put in our dy. And that's what the question is asking us, just to set up the integral. So I mean, you just have to visualize, draw your graph, see what's going on. Take a thin section, figure out the area of that thin section, and just put it in an integral. All right, let's do part B. All right, guys. Part B is saying state, but do not evaluate the integral that gives the volume of the solid obtained by rotating about the line r equals y equals 2. All right, so we're no longer rotating about the y-axis. We're rotating about a specific line, and I'll draw it here. It's y equals 2. Now let's draw the plots we had before. We'll draw them in blue. So we had y equals 1. That's better. That could be done better. Y equals 1. And then we have root 1x and ln x. So this is our region here that we're going to be rotating about the y equals 2 line. So if you rotate this, it's hard to visualize, but you're gonna get a cylinder type method, type of object. It's a shell. It's called the shell method. You're gonna get an empty shell, but it's gonna look like a cylinder. So you're gonna have it'll look something like this. This is not my best drawing, but yeah, it's like a drum, I guess. Like if you're looking from the right, you'll see it's a cylinder with a width here and radius. So if I draw this on the plot that we had, and we said that this was line y equals 2, it's rotated about y equals 2. We can find the radius here, r. It would be just be the distance from here to the x-axis minus some distance here minus some distance y, which we don't know. So r would be 2 minus y. And to find the volume of an object like this, it would be 2 pi r, so the circumference of the top circle times the height, and the height would be the width, basically, in this case. So we're just putting the width h, or the height h, so that's just your bounds of your function, right? So we're rotating all this, so it's the outer function minus the inner function, so it would be just e to the y minus y squared. That would be our height. So setting up our integral would be volume is equal to the integral of a dy, and again it's from 0 to 1, so we can set it up, no problem. So 2 pi e 2 pi r 2 minus y times height ey minus y squared dy, and that's the answer. So it's not that bad. Let's move on. Alright guys, so question 8 says, in all parts of this question, f of t is the function shown in the graph below. Estimate the values of the integral of -2 to 4 f of t dt by evaluating a Riemann sum with right endpoints and n is equal to 3. Alright, so this one's pretty easy, it's straightforward. So our n is equal to 3, and Riemann sums deal with, you need to find delta x, which is your increment. So that's b minus a over n, so 4 minus -2 over 3 is equal to 6 over 3 is equal to 2. So that's our delta x. Riemann sum right endpoint is equal to the f of a plus delta x times delta x plus f of a plus 2 delta x and plus finally a plus 3 delta x plus, and so on. So we just increase the factor over here each time until we get up to where we need to. So the Riemann sum right endpoints for our case would be, so a plus delta x, our a is our bound, so a is equal to -2. So -2 plus delta x is 0, multiplied by delta x plus f of, so a plus 2 delta x would be 2 times 2, and plus, so we go all the way up to our other bound, so b, so f of 4 a plus 3 delta x times delta x. So we reached 4. We don't need to continue anymore. So we basically get -3 times 2. So f of 0, for example, you plug in x and see what you get out. You get -3. So -3 times 2, and if I plug in 2, I get 0 back. So it would be 0 times 2. And then if I plug in 4, we get positive 3. So we get 3 times 2. So the answer is a big fat 0 for the Riemann sum evaluated the endpoints. Part B says if integral from 0 to 2 of f of t dt is negative 13 over 3, what is f of negative 2 to 2 f of dt? Alright, so the integral of negative 2 to 2, can be broken up into two separate integrals of the range negative 2 to 0 f of t dt plus 0 to 2 f of t dt. And they already gave us this value here. They just told us that it's negative 13 over 3. So if I can just find this one, I have my answer. So looking at our graph, so from 0 to negative 2, and so the area that we want is this area here, right? That's what the integral is. So we don't need to really do much. We just need to do, it's a square, right? So, well, it's not it's a rectangle. So we can just do length times width here. So this length is 2, and this here is 3. So it would be, it's negative because it's below the x-axis. So it would be just negative 6 minus 13 over 3. And that gives us negative 31 over 3. It's pretty easy. Part C, if g of x, some function g of x is equal to 0 to x of ft dt. I know it's a bit of mumbo jumbo here, but what is g prime of negative 2? To know this, we have to know the fundamental theorem of calculus. It says that some function x is equal to the integral of a. This is the fundamental theorem of calculus, what they just give us. So in our case, this is the same thing. This is g of x. So I would have to take the derivative, and the final theorem of calculus states that f prime of x is just f of x. So in our case, g prime of x is just the function evaluated at negative 2. Nothing fancy. And that, if you go back up to the graph, at negative 2, we're at negative 3. That's pretty simple. All right, let's go on. Just before we go on, I just want to say that it might not be understandable the way I wrote it, but basically it's stating that the derivative of an integral function is just the function itself. So if I take the derivative of an integral, I get back just the function. I just drop the integral, and I have the function as my answer. All right. All right, guys. For the next question, we have, it says to evaluate the limit by expressing it as a definite integral. So they give us this limit here, lim as n approaches infinity, summation I equals 1 to n, 1 over 3 plus 1 plus 2i over n squared 2 over n times 2 over n. To express this as an integral, there's actually a rule there. It says that if we have an integral f of x dx, it's equivalent to the limit as n approaches infinity of your function with a plus I delta x in it multiplied by delta x. We just basically have this, we're given this, and we have to get that. So we have to compare these two equations here and see what matches. So f of a plus I to delta x means that wherever there was an x in this formula, we replace it by a plus I delta x. So there was most definitely an x in here it was an x. It's an x, but we plugged in f of a plus I to the delta x in here. So our actual function, original function, f of x, is, that's the function we're dealing with, because if we can see here that a plus I delta x is in this parentheses here, so a plus I delta x is 1 plus 2 over n times I. So our a is equal to 1, and our delta x is equal to 2 over n, you can see from there. So if I take this, and I do f of x, f of a plus I delta x, I just, wherever there's an x, I plug in a plus I delta x, I will get back this formula, this equation here. So, carrying forward, now that we found our a, we just need to find our b, because that's our upper bound of our interval. So we know that b minus a over n is equal to delta x, and we're given, we have delta x, so 2 over n is equal to b minus 1 over n. Your n's will cancel out, and you'll be left with b is equal to 3. So now we basically have our interval set up. It's the interval from 1 to 3 of f of x, which is 3 plus x squared dx. So you could see that this integral is almost, if this was a 1 over here instead of a 3, our integral would simply be arctangent, right, of x. So we want to make this a 1, and so we can actually have a simple integration to do. So let's declare that our x is equal to root 3 u times u. In doing this, we will obtain the right format that we need. So if I declare that, then u is x over root 3, du dx, derivative of u with respect to x, is 1 over root 3, right? So that means dx is equal to root 3 du. So if I go ahead and start plugging stuff in, I'll get the integral of 1 to 3, 1 over 3 plus brackets root 3 u squared, and multiply by dx is root 3 du. So now we can see that if I distribute this squares term here, 1 to 3, 1 over 3 plus 3u squared, and this root 3 times root 3 du. Now I can pretty much factor out the numerator and 3 from the denominator, so I'll get root 3 by 3 is equal to, well, 1 over u squared plus 1. So now I have it in the easy simple integration, which is going to be just arctangent of this. So the answer to this integral is root 3 arctan of u. Yeah, I spelled that totally wrong. Arctan of u. And I can plug back in, evaluate it from 0 to 1. So I can plug back in my u. We said what u was x over root 3, so I get root 3 over 3 arctan x over root 3, and evaluate it from 0 to 1. In evaluating that, we get pi over 6 root 3. So we have successfully changed a limit format to a definite integral. Alright guys, next question is that suppose that the integral from 0 to x 1 minus e to the x over e to the x plus 1 dx is equal to negative 1. It's asking us to find negative a to a integral of that same function without finding the antiderivative of the integrand. So non-traditional methods. They're asking us to use the basically we have to find whether the function is even, because there's in your textbook you'll see, sorry about that, in your textbooks you'll see that there's a formula where you have negative a to a, which is this right here, of some function times dx equals 2 times 0 to a f of x dx. This only applies if f of x is an even function. So if we can, we have f of x here, our f of x is equal to x1 minus e to the x over e to the x plus 1. If this is an even function, we can state right away that the integral of negative a to a of this function is equal to 2 times our function integral a to 0 to a. So let's find out if it's even. To do that, we have to plug in negative x, and if we get back the original function, we have an even function. So everywhere there's an x, I turn it into negative. So negative x 1 minus e to the negative x over e to the negative x plus 1. So we can now manipulate this. So say we do this. 1, we bring this e to the x over here, and as well as this one here, plus 1. And if I take, if I multiply both sides by e to the x, I would end up getting the following. Negative x e to the x minus 1 over 1 plus e to the x equals x 1 minus e to the x e to the x plus 1. And that is our original function. So recap, distributing this e to the x here and here, you get 1 plus e to the x. Distributing this e to the x here, you get negative x e to the x, and this term becomes 1, so you basically have your functions spit back right at you. So it is even. Now we can state comfortably that the integral of negative a to a of our function, I'll just write function to simplify, here as 2 times integral 0 to a f of x dx. And so we're given this value, this function of this integral. It's here, it's equal to negative 1. So you have 2 times negative 1. So the answer to this question is 2. So I suggest you go over this on your own if you can. Just plug in your negative x, try to get back the original function. I know it's a little bit of work to manipulate this to make it look like the original function before you plug in negative x. It might not be that obvious. So keep practicing. Let's move on. Alright guys, we've reached the end of part 3. We're going to move on to the next couple of questions in the next video. Just don't forget to like this video and share it with your friends so that they can gain some knowledge as well. And don't forget to subscribe to support me.